This section is going to be a little bit mathematical for you. The exercise is actually quite nice. It's what we used to have to do to create graphics and create games. If I just quickly show you the worksheet. So we're going to talk about creating pictures, which are like this picture of a bomb, and how you can go about putting in numbers so that each pixel turns on and off as needed. Now, in terms of what I've coded here into this spreadsheet, purple is just what you're supposed to try and create. White is off, 0. Black would be on. So if I put in a 1 here, put it into the yellow box. So I put in a 1. That's indicating that the binary coding for this number is 1. It illuminates this last place. If I put in 2, we'll talk about why this happens in a minute. I put in 2, it goes to there, 3, both of them turn on, 4, and suddenly this bit turns on. So you should realise now, this is built up by adding numbers together, and the numbers being added are 1, 2, 4, 8, 16, 32, 64, 128, and it continues. But 4 means just turn that bit on. So if I want to turn that one and that one on, think about it for a moment. That's a 4 and a 2, so I can put a 6 in. And that will turn on all of those. Now, if you don't need more explanation than that, you could probably go in and start coding all of these characters. So I've got a letter A, capital letter A, an hourglass, the ghost Blinky from Pac-Man, a flag. Then the second part of the lesson is to go on and decode these numbers. So you need to go through and put the picture in and describe what it is. It doesn't automatically check this bit. All that happens is you put in. And the way you can put a code in is if you think that this needs a code in there, you just have to put a character in and it will shade it in for you. So if I put in a 1, then it doesn't matter what you put in. You can put in a star, you can put in a backslash. It doesn't matter what it is. I would avoid things like spaces. Yeah, the space doesn't deal with it. So any character that leaves a mark normally, if you put it in, you can shade these in. So a little tip for you, this line, there's 0, nothing's turned on, so nothing should be black. You're only filling in bits which are in the blue sections on this. And then as an extension, you've got 4 spaces there to create characters of your own. You might want to create the Cyrillic alphabet. You might want to make some characters for your game. So your game that you were doing on the adventure game, you might want to create a little picture of a man, a wizard, so that we could use a graphical interface to put on yours. It's up to you how you want to do it. Just make sure you're clear what in the bottom what things are. If you need more characters, you can select. Oh, I need to go back in a minute and remind you one thing. If you select the numbers down the side, you can press Control-C, go to the top of the next section, press Control-V, and it will create new lines for you. And if I put in a number 24, it's filling for me again. Okay, so that's how you can go through and do the exercises. Please don't ask me to give you write access. Remember, it's File, make a copy, and you make a copy into your own area. I'm now going to go on and explain a bit more about them, how we build them up, how we show what's going on, and I'm going to put some numbers into my sheet to make a copy. So I'm just going to make a copy now. So File, make a copy, binary encoder, or binary coder, PB. This is my version, and it's the one I'm going to work with. So once I've created it, that's mine. And you can zoom on these. I'm going to just zoom in on using that zoom tool there so I can make it most of the screen size without changing the fonts around the top. So that's what I'm going to be using in a few minutes when I've done the basic explanation. If you're completely happy with binary, go off work now. Otherwise, I'm going to do an introduction as a mathematician. Okay. Right, binary system then. Let's talk about our number system we use, and it's called a denary system. Den or dec means 10, and our number system is made up of, we start with a decimal point and we go 1, 10, 100, 1000. And then next to each number, when we put the numbers in, we get 4, 5, 2, 7. And this number we know is 4 thousands and 500s and 20 plus 7 ones is 7. And that's how the denary number system works. That's what each place holds. And that's what it's talking about doing. We're going to be talking about the binary number system. Bi means 2. Bicycle, biped, bi means 2. The binary system, when we go back to the denary system, each number space can have 1 of 10 characters. Don't forget 0 to 9. Binary system says that we can only have 2 numbers in our system. So we've got 0 to 1. So my first value, again, decimal point and 1. And I can do 1, 1 is 1. But when I want 2, I can't put a 2 in here. There's no character number 2. So we have no character 2. So we must go to the next column. So there's my 1s. Next to it are values that are worth 2. And this is a denary 2. The binary system doesn't know of it as there being a character 2, but we think of it as 2. So I can now do 1 and 2. So if I put 1 and 1 there, that gives me 3. My next problem is I need a 4. Well, I can't do anything here. I can't say 2 2s. Can't say 4 1s. It's not allowed. So to create the 4, I need a 4 column. So when I put 1, 0, 0, we now read that as 4. So I can keep going up. Next one, I can go 4 and 1, 5, 4 and 2, 6, 4 and 2 and 1 is 7. And 8. I've got no way of putting 8 into any of these columns, so I need a column of its own for 8. So 8 is 1, 0, 0. Go through again, I can do 8 and 1, 9, 10, 11 by doing both of those. And 12 is 1, 1, 0, 0. At this point, that's where some people normally start losing. They think they've got it, and they go a bit too quick. And 11 and 12 often confuses people. 13, 14 would be, so 13 would be the 8 on, the 4 on, and a 1. 14 would be the 8, 4, 2, and no 1s. And we get as far as 1, 1, 1, and that is 15. I filled it up, need to go into the next column to create my 16. Okay, so that's what the binary system does, and that's how you can think about it in binary counting. What if I actually want to put the binary in for a number? So I'm going to put binary in the middle. We've got 1, 2, 4, 8, 16, 32. There are, actually let's go for 64 and 128, because they're the ones we need. Choose a random number. Let's say I want to encode 20, let's go for 29. The way to code it is you find out the most significant bit first. So we're looking for the MSB. Which bit can go into this number most? 128? No. 124, 64? No. 32? No. Sorry, I meant 64, not 164. 16? Yes. That's my most significant bit. So now I've done 16, I've managed to code the 16. So I minus the 16 from it, and that gives me 13 left. I look at the next numbers I can code. Can I code 8? Yes. So now I've got 13 minus 8 is 5. 5, can I subtract 4 from 5? Yes. So subtract 4 from 5. And that leaves me with 1. Can I subtract 2? No. 2 is greater than 1. So put a 0 in for 2. And then I'm left, therefore, can code that into 1. So the number, binary number, 1, 1, 1, 0, 1, in binary, sometimes written with the 2 underneath. You'll see in computer science quite a lot, a B in front, 1, 1, 1, 0, 1. And that is equal to 24 decimal in base 10. Mathematical form. And this is computer science form. They often put a B in front to say it's binary number. Well, sometimes people put it afterwards. But mathematically, I think is a little bit more elegant. Let's do a second example of this. Let's try 100, nice round number. So 100, 128, no. 64 I can, so subtract 64 from it. And that leaves me with 36. 36 into 32, yeah, I can subtract 32 from there to give me 4. So I'm now looking for 4. Don't need a 16, don't need an 8, but I now need 4. 4 is the biggest number. Wait. 4 is the bit that's left. There's nothing left over, so 4 minus 4 equals 0. All remaining places need to be zeros. So now I can say 100 is written as 1100,100. That's 100 decimal. Okay. What about going the other way? So let's reverse it. I've now got a number and I need to know which values is it. So I'll put the codings in again, 128, 64, 32, 16, 8, 4, 2, 1. And I'm going to say I've got this following number. 11001100. And I'm going to do one other thing in a minute to link to this. Going the other way, relatively straightforward. All we do is we look at everywhere we've said we've got a number. So we've got no 128s, no 64s. We've got a 32, a 16, no 8s, no 4s. We've got a 2 and a 1. So 38 and 16 is 48, plus 3 is 51. Okay. Some of you might have realised there are binary systems on calculators as well. So if I actually bring my calculator in, I think I can do it in here. Let's check it. 51 decimal. And I want to change the mode. So I just saw it, mode to base. I want to go into mode 3, base, and I've got 51 as a decimal. I want to change it to binary, so I use the log key, and it gives me 110011. Let's go up. Let's try 1100,100 binary, and I can do 2 decimal, and that's 100 decimal. Okay. Most calculators in some form have that function. Right, the last quick note is to think about quick ways of finding certain combinations of numbers. And the easiest one is always when you're filling from the right. So if I've got 1 in this position, that's equal to 1. Everything else is 0. So let's fill up 2 and 1. What's 2 and 1? Well, that's 3. So this is linked. There is a link between this and the headings. Next number, 1, 2, 3, 4, 5. This is 7. Hopefully some of you have started realizing how this pattern works. So when I go to this number here, where it's 4 ones, we look at the number, we add them together, 8, 4, 2 and 1, that's going to be 15. And the reason I've already explained why this works, is this is the biggest number 4 digits can hold. The next place must be the next number. So all of these are actually the next value up. So I'll just circle them. So that one's a 2, and that's 2 minus 1. It's 1. This one is a 4. 4 minus 1 is 3. Next number up is 8. 8 minus 1, 7. Next number up is 16. 16 minus 1 is 15. So I'll give you a moment to think about this one. What would 5 ones be? 5 ones. Next number up is a 32. So 32 minus 1 is 31. Let's try 5 numbers on the calculator. 5 ones on the calculator. Press equals. Oh, that's in denary. Cancel. Let's go to binary mode. 1, 2, 3, 4, 5 equals, and change it to decimal. 31. So let's apply that now to my sheets. Sheets are that one. So let's have a look at this challenge one over here. I want those 3 numbers on. My headings are, and you can actually, I will go back and I'll put in here inserts so you can put headings above them. So if I highlight these numbers now and change the color so that they're black, you can see them: 1, 2, 4, 8, 16, 32, 64, 128. So I need a 2, a 4 and an 8. 14. Type in 14 and they've all gone black. I need a 16 and a 1. That's 17. 64, 32. Well, I can actually go through that. This is 127 if it's full. Take off 2, take off 1. That's 124. So I can fill it in that way. So this bomb or apple shape, you've got A's and hourglasses to do. And then you've got the flip side to do on section 2. And I'll make sure there is a line in front of this as well. I want to put a row above it. So you can actually put in your numbers. You need to type your numbers in though. I'm not going to tell you all of them. So this is 1, 2, 3. I'll need to change this so it doesn't do the chain. The formatting. I hope this will have been done for you when you come in to this one. For that line, I'm going to move K6, moves that, so it's there. 1, 2, 4. You need to learn to put these numbers in for yourself, and they're just powers of 2. So I want 124, so I'm going to put, it doesn't matter what character it is, but if you put a mark into here, it should shade it. That's what I've just done. I've just removed all of the shadings I wanted. Okay, 39, that to be reduced to K34. So I can move that one, this one. The region is 40. I can put them in. Get off. I didn't want a new rule. Done. So I can now put in 4, 8. Just reading the wrong number now. Okay, I'm going to take these numbers off and I'm going to work on the one on the left there. Actually, let's go back to the basic. There will be a space for you to put your numbers in on yours. So first 128 doesn't go into 127, but 64 does. That needs to move 63. 63, 32 does. And that leaves to move 31. 31, 16 goes into 31, 15 left. So 8, yeah, I've got 7 left. 7, 4 goes into 7, yes, 3 left. 2 goes into 3, yes, 1 left over. And that gives me my 127. And when you go through and do these, you should see a shape, hopefully one that you can fill in. Okay, so that's the video for your binary system. Oops.